So, I'm not really sure if there's beer in the other room, but you guys are making a really great sacrifice to come to my talk if there is, so thank you in advance for that. So hopefully there'll still be beer left afterwards. I'm sure there will be. So, all right, I'm Melanie.Rieback. I'm now an assistant professor at the Vrije Universiteit, the Free University of Amsterdam. I work, primarily my work is on RFID and security. You guys already know a little bit about RFID today from Lucas Grunwald's talk. I'm basically sort of tackling the whole thing from another angle. And I'm working on something called the RFID Guardian that I'm going to describe to you today. So I'm actually going to skip this slide because I'm going to assume pretty much that everybody in this room knows what RFID is. And you also know, undoubtedly, that it has a number of security problems. Unauthorized tag reading, I mean, certainly with spoofing, Lucas was talking about this with the passports, eavesdropping on not just signals from the tags, but also signals from the reader that sometimes divulge information. Traffic analysis is also a problem. Tracking, of course, RFID, I mean, they're like these radio barcodes on steroids. You know, it's a technology meant for tracking. But of course, as soon as you get private personal data involved, this becomes problematic if you don't have the consent of the people who are involved. Tag cloning, once again, Lucas talked about this earlier today. You can make copies of these things, and if it's your passport, or if it's an ExxonMobil speed pass, or if it's, you know, it could be a problem. So. Additionally, denial of service is another one of these things. You have to remember that RFID technology is actually evolved from, you know, that anti-theft technology. So if you go to a department store and you have these little tags on your sweaters, well, basically, I mean, if you think about computing in the last couple decades, I mean, Moore's Law has basically taken, it was, you know, from mainframes to mini computers to the PCs to, you know, the little PDAs and down to sensors, down to RFID. Well, the point is that Moore's Law basically took these anti-theft tags, and now instead of just having one bit of information that essentially says this item has been paid for or it hasn't been paid for, now all of a sudden it has 1K bits worth of data, 2K bits worth of data, 2K kilobytes, 16 kilobytes, all depending on the kind of tag that you're using. And there's actually a really wide variety of RFID tags, from contactless smart cards down to the little, you know, 10-cent tags that they want to use in retail. But the point is, there's a lot of threats against these, and well, with denial of service, essentially with the anti-theft tags, if you prevent the tag from working, you've defeated the system. And it's actually similarly with RFID, that oftentimes, if you have a RFID tag that's also used in retail, if you can prevent the tag from working, then it's one way of defeating the system. I'm going to talk a little bit about another security problem, RFID malware. It's actually going to sound like a repeat, once again, from Lucas's talk, but because he was discussing putting JPEG photos on the RFID passports that you could use to exploit the back end of the system. But I'm not sure how familiar you people are with my work. I actually was the first person to publish on the whole topic of RFID malware. So, what is it? I mean, whereas the previous threats that I discussed were really high-level abuses of RFID tags. In other words, you were still doing valid operations with the tags and just causing, on the application level, unintended consequences. As RFID malware, all it is just taking the same old hacking attacks from the security domain and transplanting it into the domain of RFID. So when I first published about this, all of the security people were like, well, yeah, duh, you can put, SQL injections onto RFID tags. I mean, well, duh, you can put buffer overflows on these things. We knew that. But of course, the RFID industry, on the other hand, were caught a little bit by surprise. So there's three main kinds of RFID malware that I discussed in my paper. The first of which were just really simple RFID exploits. These are, as I mentioned, like SQL injections, other kinds of code insertion attacks, buffer overflows. We actually demoed a buffer overflow, basically using a 1 kilobit buffer and a 2 kilobit RFID tag. I mean, everybody thinks, oh, you can only put, so little space on these data on these tags. How can you do a buffer overflow with that? But literally, I mean, it was enough extra space that we were able to basically, put the jump instruction, put the address in there, have our own little custom shellcode that basically executed, regedit or something. So we actually put a demo of this. And if you actually want more information, including about 30 different code samples of RFID malware, all you have to do is go to www.rfidvirus.org, and you guys can find anything you ever wanted to know about this particular kind of research. So RFID worms, the whole idea behind an RFID worm was simply that, okay, an exploit is fun. It just operates once and then that's it. Well, the next question was, can we make these things self-replicate? Can we make it so that you have an exploit, it invokes itself, basically, and then it somehow makes a change to the back-end middleware system so that it then can write itself back to new tags that appear. Because then essentially what you wind up having is you basically have this infection. It spreads from tag to reader to more tags to more readers. And assuming that you're using standard backend middleware, which of course remembering that big players like Oracle and SAP and IBM, like WebSphere, are involved in making middleware, chances are a lot of them are going to be using not only compatible standards, but also compatible backends. So we did an RFID worm. The only difference between our RFID worm and our RFID virus was simply that, like normal worms and viruses, the worms we assumed required the help of a network connection to spread. So in other words, they basically invoked an exploit and then grabbed some malware from the internet, executed that, which then caused the change in the backend middleware, which then caused the infection to spread. Well, with the RFID viruses, we actually showed a way of how it could self-replicate without requiring an internet connection. So I don't want to talk about this too much more. This is actually not what this talk is about, but the organizer specifically asked me to discuss it. So yeah, if you want to know more exactly about how this works, rfidvirus.org, and well, that's a whole nother talk. It did actually have one thing that's kind of funny. I decided one time to take a look at RFID on Google Trends just to see, and what you can actually see here is. It's a little hard to read here. The top basically is the frequency of the searches for RFID over the past couple of years. And then the bottom line down here is the frequency of news hits for RFID in the past few years. If you take a look at the second line with the news, you're going to notice you have a lot of fluctuations and you have a peak around here. And that peak was at right about February 2006. If you take a look at the marker up there, C is above that peak, and C was that RFID tag's vulnerable. And indeed, if you click on that link, it'll bring you to this, which basically is a news article talking about our RFID malware work. So literally, I mean, I knew times were crazy when this happened. I hadn't expected this, but apparently our RFID virus scare was like the #1 news topic on RFID ever. So to see from Google Trends, at least as long as they're keeping track. So that's kind of, I thought that was kind of funny. Anyway, enough about that. I'm going to talk about the RFID Guardian now. So what is it? It's something that's evolved over the years, but one thing that it is it's a handheld mobile platform for RFID security and privacy management. So this is not a security or privacy feature that goes on an RFID tag. A lot of researchers do research on how do you put lightweight security protocols on RFID tags, how do you put lightweight crypto onto RFID tags. I think it's all wonderful, valuable research, but I decided to tackle it from another angle. So the angle that I'm taking it from is how do you take a computer, how do you keep a battery-powered computer or something that you plug in, and how do you use that kind of as a third-party device to help enforce the security and privacy of RFID tags on their behalf, so for them. So it's off-tag protection, not on-tag protection. So the basic idea is the RFID Guardian at its core is just a software-defined radio. Shouldn't be so exciting, right? But what we've done is we have basically put in some stacks, written some stacks ourselves. So it's an RFID tag emulator, first of all. So we can spoof RFID tags. We can talk RFID tag protocols. And the other thing is we have an onboard RFID reader. So we can also act like a normal reader and perform all the usual queries on RFID tags. This is one of the basic building blocks that allows us to build more complex security and privacy functionality, as I'm going to explain. And then basically, I'm going to show you now a video that demonstrates another piece of functionality. So besides spoofing, we can also do something called selective RFID jamming, and we're going to demonstrate this in this video here.
Okay, I have a book here. We've attached to the book an RFID tag. And in the future, all books and many other products will have RFID tags attached to them. And now I'm going to demonstrate how the RFID tag is detected by the reader. So I'm going to move the tag in the book over to our reader over here. And you'll see on the screen, connected to the computer and the reader, that it's detected. So I gradually move the book within reading range. You see it appears on the screen. I move it away, it disappears. I put it back, it's going to appear again. And I'll balance it on there gently. Okay, so you see that the tag has been detected. Now, I have a piece of clothing. And clothing also has an RFID tag. In the future, clothing will have RFID tags. So when you put the clothing in the washing machine, a smart washing machine will be able to ask the clothing at what temperature do you want to be washed, and the clothing will answer directly, so no person has to set the parameters on the washing machine. In this case, we put the tag on ourselves. Later, it will be sewn into the clothing. Okay? Now I'm going to go over to the reader and put this within range, and you'll see that this is also detected. There on the screen, it's coming. It's noticed it, we move it away, it goes away, we come back. It's detected again. So, the reader is detecting both objects at the same time. You can imagine that not everybody is happy with the idea of random strangers reading out the tags in their clothing at a distance. So part of our research is to build a device which will help protect your privacy. This device we call the RFID Guardian. We built a little prototype of it. And over here, you can see the prototype. It's a little board with some chips on it and some analog electronics for managing the radio. It's got an antenna, okay? And the idea is you could carry around a smaller version of this, perhaps integrated with a cell phone or a PDA, and then it would block the scans of hostile readers looking at tags you don't want the world to see. Now we're going to demonstrate. When we turn on the Guardian, then the piece of clothing will be blocked, but the tag on the book will not be blocked, okay? Now turn on the Guardian, and you see over here that the piece of clothing has been blocked, but the book has not been blocked, because the Guardian has been set up to block one of the tags, but not the other one. So in this way, your privacy is protected.
All right. So that's our video. By the way, in case you were wondering, that balding guy in the video is Andrew Tannenbaum, who is my boss at the Freie Universität. So if any of you guys know about Minix or some of his computer science books, well, anyway, enough. Yeah, you've now seen him in women's lingerie. So anyway, RFID Guardian version 2. So this is basically what you saw in the video, and I'm just going to really quickly point out some of the sort of salient and exciting features of the hardware. So first of all, what we've got, this is the front of it. We basically have this right here is something called a CPLD, which is a lot like an FPGA. We're using this essentially for the bit modulation, the encoding, decoding, these kinds of things. A lot of the radio. This right here is the RFID reader on a chip. So you remember that little reader that we had in the video? Well, essentially this little thing right here on the chip is exactly the same thing. It's from a company called Melexis. So if you flip the thing over, another thing you have right here is something called a Triton development module. What it is a PXA270 processor. So really just like the same kind of processor that you have in cell phones, in PDAs. So we picked a real CPU with a lot of horsepower just because we wanted to really do a little bit of overkill and really show what you could do without having to worry too much about timing constraints, because there's a lot of real-time constraints with RFID. But it also has flash memory, SRAM. It's basically a computer. For the rest, as you'll notice with version 2, I mean, these little yellow things that are kind of up here, these are bug fixes, ignore them. But yeah, it was put together with love, so. Right, so RFID Guardian version 3, we actually do learn from our mistakes. So the reason for the bug fixes were that, okay, we kind of screwed up a little bit with version 2 with the impedance matching of the analog front end. So version 1 actually well, version 1 was just on proto board, and it was it looked like Frankenstein, it was just, little wires everywhere. But the point is, with version 3, what we actually have now is it's really pluggable, and we decided to take the same kind of modularity principles that you have for software and now implement them in hardware. So what we've got is essentially a backplane. It's actually like if you think about a PC, how you have like motherboards and little like baby boards that you can plug in. It's the same thing now with the RFID Guardian. So you have a whole lot of connectors. Here in the middle, you still have the FPGA. We're now using an Altera FPGA. But now you have a place where you can plug in the analog front ends. See, this is a good thing, not just because, if you design an analog front end and completely screw up, you can just unplug it, redesign the piece that's broken, and then plug it in again. But it's also handy because not only can you design an analog front end, let's say for high frequency RFID, like 13.56 megahertz RFID like we showed in the video, but you can also do 125, 135 kilohertz analog front ends, like you would have, for example, for the Vera chip that people inject into their arm, or the little chips that you put into your pets, Fluffy, your dog, cat, fish. Also, 860, 960 megahertz. If any of you guys have ever heard of EPC Gen 2, this is also one of the kinds of RFID that is, like the Department of Defense and Walmart are going crazy over this one. We want to be able to support it too. It's certainly one of the largest standards, but it requires yet another analog front end. Of course, someday we hope to integrate these things, but for right now, we're still sort of in the phase where we're trying to get everything to work. So, so for right now, pluggable is really handy. Also, there's a lot of RFID at 2.45 gigahertz. I'm sure some of you are familiar with RFID in containers and pallets, and a lot of things where you really need a longer range RFID. Also, active RFID tags, the kind of RFID tags with batteries, those also operate at UHF at 2.45 gigahertz. So we're also working on building an analog front end for that. So that's really handy. We also have pluggable bits for, you can see up there at the top, there's a place you can put a TFT touchscreen. Right now we have a EE student who's working on developing a board for that. We have a whole bunch of GPIO pins, just so you can add your own random stuff. There's also a JTAG header, which is useful for debugging the hardware. And up in the corner, it's a little hard to read here, I'm sorry, but there's also a place where you can put a Bluetooth module. Now, I know you guys are going to recoil in horror at, this is supposed to be a security device. Why on earth do you want to use Bluetooth? This is true. The reason why we want to use Bluetooth is because if we have one of these devices, you don't want to constantly be futzing with the thing. You just want to be able to maybe put it on your belt and forget about it, or just put it in the corner and forget about it. And our idea with Bluetooth is that you can basically whip out your cell phone if you want to make any changes. Use actually the user interface on the cell phone to basically make whatever changes you need to. Put your cell phone back, and then you're done. And this is actually what we've implemented, and I'm going to show you some very pretty photos. But yeah, in terms of Bluetooth, this is the reason why we're using SSL over Bluetooth, because we don't want to deal with those security issues too much. But yeah, that's sort of the idea. And actually our grand vision for the RFID Guardian is that eventually you could take the analog hardware that we have built and put it on one chip. So what we have built, just in terms of an RFID reader and an RFID tag emulator, a software-defined radio at its essence, is not much more complicated than near-field communications, which is also a sort of RFID. Philips has already put NFC on one chip. Nokia has already put the NFC chips into phones, and we think that you could do the same thing with the RFID Guardian. Minus the antennas, of course, which you'd have to plug in. These things you can't reduce. Or you could reduce them, but then the operational range would become worthless. But this is sort of our vision. And also that kind of helps with the whip out the cell phone. It kind of gives people the idea of where we think this technology maybe someday could go. So, all right, here's actually a picture of the Bluetooth module that we made. We're using the Linkmatic Bluetooth chip for that. We're also using Nokia cell phones, so we're using the Nokia E60 and E61, and you can actually see a picture now of our main menu that we've implemented. First of all, I also want to say I'm covering a lot of territory really quickly here. We actually just recently submitted a very new research paper on all of this. It hasn't been published yet, but well, we're hoping it's going to get accepted to the conference we sent it to. So at some point, a lot of this information will be available as soon as the paper is accepted in a publication. But I also should say that a lot of this information is also available on our website, which is www.rfidguardian.org. So you can, so if you want to know more, for example, about the user interface on the cell phone, there's lots of information right now that's online. So, all right. So version 1 was Frankenstein. Version 2 had, our bug fixes. Well, with version 3, we were finally deciding we want to make this a little bit more professional. So we actually got this now produced in China. Right now, with this particular version of them, we have 10 of them actually that we've been prototyping. We have 7 of them assembled. And this is the PCB. And once again, you can see the whole motherboard, baby board idea, because here is the back plane. And here are all the different baby boards. So in this corner, you have the board that you plug the little Triton module into. Above here, you have some power management circuitry. Next to that, you have a sampling board for AD conversion. And along the top, you also have actually, look at the screen so I can. Yeah, you have an RS-232 board for the serial cable. You have an oscillator board. You have the JTAG board. And also in the upper right-hand corner, you basically have a little user interface board for 3 LEDs and 3 buttons, because everybody likes blinking lights. So if we assemble it, this is what it looks like. Once again, we're still in our prototyping phase. We're still just trying to make sure that everything works. You're going to notice that version 3 is larger than version 2. We had different objectives with the different versions. Version 1 was like, let's prove that this works. Version 2 was let's make it cute for the photo. And now with version 3, it's sort of like, well, okay, let's make it work again so we can really do rapid development with this. And I have to say, we're also going to soon be coming out with a version 4 that we're going to try to make cute again, and then hopefully actually be able to mass produce and sell to people. So I'll talk about that a little bit more at the end. But this is version 3. So, okay, you've seen our beautiful hardware. What does it actually do? Tag spoofing. You, I believe, saw this. No, actually you didn't. I have another video on my website that shows tag spoofing. So RFIDguardian.org if you want to see the video. But if you want to know how to spoof RFID tags, I'm going to give you a really quick overview on how to fake RFID tags. So this is sort of the canonical photo of what an RFID tag signal looks like. Essentially, you're going to have a peak here around the baseband. So this is 13.56 megahertz in the system that we're using. And on either side of it, you have these 2 little peaks that are called sidebands. And essentially how RFID works is it has a little load modulation resistor. And essentially the RFID tag just flips the little resistor on and off in time with the clock signal. And that's the way that it transmits data back. So it's then the job of the RFID reader to filter out this, because this is just information that the RFID reader itself is sending. So it knows this stuff already, so it doesn't care. So it just wants to filter out its own signal and just get these 2 little bits of information right here. And the timing of how these little peaks are sent is completely dictated by the standards. And the standard could be the ISO standards, it could be EPC standards. But basically what we do now with the RFID Guardian is you're going to notice here, this is the carrier signal. So this is 13.56 megahertz. But now you're going to see 2 really whopping big peaks. In fact, this peak on the left here is even bigger than the carrier frequency. And these are actually our sidebands that we're producing. So why are the sidebands so big? Well, first of all, we are actively transmitting the sidebands, while our RFID tags only passively cause the sidebands to happen by modulating the RF field. So essentially, because we are actively transmitting these frequencies just with a normal transmitter, the operational ranges of the RFID Guardian are much, much, much larger than what you could expect from an RFID tag, simply because we're operating with different principles. Oh, I think I broke it. Okay, well, anyway. Oh, hold on. Oh.
Oh, how did you?
I don't know, you can't, you totally cannot take me anywhere. It's just, all right.
Okay.
All right, very good, thank you.
You're welcome.
So, sidebands. Essentially we can get, well, right now with, the largest operational range that we've seen so far with 13.56 megahertz is 60 centimeters, which isn't huge, but we're still working on optimizing this with our current analog front end. Theoretically, with HF RFID, you could get it up to 2.5 meters. In terms of LF, it's probably going to be smaller. In terms of UHF, it's definitely going to be a lot bigger. So really, the answer of how long can the operational range of the Guardian be? I mean, the answer is, for the most part, it depends on the frequencies that you're using. Of course, keeping in mind that with the RFID reader that's attached to the Guardian, that's actually going to have the greatest range limitations, because if you're trying to communicate with RFID tags, it's the tags that are going to have the real limitation. So with RFID tags, if the nominal reading range is 10 centimeters, we can't do a heck of a lot about that, unless you want to, put so much power into this thing that you can cook pigeons with it, but I'd rather not. So, right. So tag spoofing. So here's how it looks when you spoof. You can basically see we just made a whole bunch of really fake-looking tags, so a whole bunch of zeros, F0, 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 F01, et cetera, et cetera. So we have spoofed successfully so far. Well, we weren't really being methodical about it, but we were just like playing with it one day, and we were like, how many tags can we spoof? We got up to about 200, and then we said, okay, that's probably good enough. Another thing we can do is spoof and jam at the same time. So another kind of cool demo that we have is if you have the RFID Guardian, and this is really fun to play with. You can have, two RFID tags sitting on the reader. You can have your Guardian. You can actually put the Guardian next to the reader, and all of a sudden, one of the tags will suddenly change into another tag ID. So it'll actually spoof one of the tags that are there, jam one of the tags that are there, and then replace it with the tag ID that you're spoofing. So it's like all of a sudden, you put it closer, you see the little ID flip, you put it away, that flips back, it's kind of fun to play with. So this is one of the things we can do. Selective jamming. So we can jam both RFID tag responses and also RFID reader queries. So I'm going to talk first about how we jam, selectively jam the RFID tag responses. So with ISO 15693, which is as good a study as any, it uses an anti-collision algorithm called slotted aloha. So anti-collision, for those who don't know, is just a simple way that if you have multiple RFID tags and you ask them, okay, tags, who is here? You need some kind of an algorithm to prevent them from all saying, I'm here at the same time. So essentially what you do is you just assign 16 time slots, and you have the RFID tags more or less pseudo-randomly generating picking a time slot based upon, actually what they're doing is XORing their tag ID with something called an anti-collision mask and it's using that to pick the time slot. But it sort of seems pseudo-random when you're doing it. So because there's an algorithm that we understand that they're using to choose the time slot, all we have to do is, for any given tag that we want to protect, we have to calculate the particular time slot in which it's going to be speaking. So we can calculate based on the tag ID, if tag 1234 is my passport, I know then that in time slot in round 1 of anti-collision that it's then going to be speaking in slot 14. So then in round 1 you send out a jamming signal, and when I say jamming, I literally mean signal warfare jamming. Like we are just sending out random noise to increase the noise to signal ratio high enough that essentially you just can't pluck out the tag response anymore. And then it blocks any tag response in slot 14 or whatever it was. However, then if the reader detects a collision, it goes to the next round of anti-collision. All of the tags that really are there and aren't being protected then in the next round choose a different time slot. And the point is that the RFID reader will actually go through 16 rounds of anti-collision before it gives up. So, I mean, essentially, at that point, you have a 16 to the 16th chance of actually, jamming tags incorrectly. So, yeah, which means it's probably not going to happen. So in such a way, we can actually always get RFID tags to be jammed by just simply calculating when they're going to speak and only jamming that time slot. I also have to say, people have also asked me, but can't you make some kind of a fingerprint just based upon when the jamming occurs? The answer to this would be yes, but our technique for that is essentially if you occasionally also throw in a jamming signal when there doesn't need to be one, you can actually throw in some chaff with the wheat. So it actually makes it harder for an attacker then to be able to try and make fingerprints on what tags are there based upon what time slots are being jammed. So, but once again, this is still a work in progress, and it's a cat and mouse game like anything else. So, RFID reader query jamming. This is not yet public. This is not yet online. You guys are hearing it first here. How do we jam now RFID reader queries? I mean, with RFID tag jamming, that's only effective because if you're doing things like read queries. So, or if you, for example, if you want to ask which RFID tags are here, and then your passport says, "Hi, I'm here," blocking the tag response is useful. If you ask, "Okay, passport, could you please send me, some of the data groups so I can see, what your fingerprints look like?" You're essentially sending a read data block, and then when you block it on the way back, that's also useful because it can't get your fingerprints or whatnot. However, RFID tag response jamming is not useful for things like write queries. If you want to write data to a tag, I mean, there is no response that you can block on the way back. So essentially what you actually need to do is intercept the RFID reader query as it's outgoing. And other kinds of queries where you need to intercept the outbound RFID reader query are for things like kill tag commands. Because of course, once you deactivate a tag, it's dead. So you need to catch it before it actually hits the RFID tag that you're, for example, trying to DOS. So here's how we do it. You have RFID frames. RFID, just like anything else, they usually have start a frame, bits, checksum, end a frame. So what we do is when the start a frame and the bits come in, we basically take a look at it and then decide, what is the RFID reader trying to do? Is it writing data? Is it writing data to a tag that I care about? Maybe I don't want data to be written to this particular tag. Then what we do is, using an access control list, we basically specify if somebody's trying to write data to or if somebody's trying to kill, an EPC tag on, I don't know, my microwavable spinach or something that I want to be able to automatically set the time for my microwave. They come up with these useless applications. Anyway, so the point is, if you decide that you don't want the tag to be written to or deactivated, you put that in your access control list. And then what we do is we actually send out, yet again, another one of these random jamming signals during the CRC and the end of frame. So, I mean, a lot of people would ask, this stuff is real time. Can you actually make that decision fast enough and react fast enough to be able to garble the CRC and end of frame? The answer is yes, we've done it. So we basically filter these outbound RFID reader queries. So as you can see here, here's the start of frame. Here's a whole bunch of bits. And then here is when the CRC starts. So we have a callback that then starts the jamming. And it jams essentially through the CRC through the end of frame. And indeed, the tag, because the CRC doesn't check out, and because the end of frame makes it an invalid frame, because there is no end of frame anymore, the RFID tag then ignores the query that was sent by the reader. So in such a way, the RFID guardian is really a man in the middle between RFID reader communications and RFID tag communications. Even though it's a broadcast medium, we really can filter things going both ways. Okay, so you're starting to see the primitives with which the RFID guardian works. Tag spoofing, tag jamming, and RFID reader query jamming. So, what do you do once you have something that can filter RFID communications? Well, our first thought was, why don't we try to build a firewall with this? So, for real. So the RFID Guardian, in terms of a privacy protection device, actually can act like an RFID firewall. So the major features, you can take one of these things and you can use it either to protect individual people or to protect individual locations. Of course, you need a battery if it's going to be on a person. Like I was saying, clipping on the belt. We'd like to do this with a Guardian too. Keeping in mind that the only tags that are protected by this firewall are the tags within the immediate radio operational range of the Guardian. So a lot of people say, yeah, but what if you have a jacket and you put your jacket on the chair and then walk away? Then it's game over, for the jacket, because, once you walk away from it, it's not in the range of the Guardian anymore, so it's not protected anymore. But these are the rules of the game, and, if you want to use the Guardian, this is one of its limitations. We can't do anything about this. However, you could also put one of these things in your living room, so then as long as you're, in your living room, then perhaps it would work. Or, in fact, at some point, maybe you could coordinate multiple of these things. Well, this is future research, but... So what are its main functions? Well, first of all, auditing. So RFID activity is just radio. It's invisible. If people are querying your passport, how are you going to know? It's not like you have this little LED on your passport that turns on every time somebody's scanning it. It's not like it has a little built-in speaker so it can say, help me, every time an attacker is trying to scan it. The point is, this stuff is invisible. What we want to do is we want to make RFID activity, first of all, just like a packet filter on a network. Think TCP dump. We actually want to try and make a kind of TCP dump for RFID. So essentially, if there are RFID reader queries, remember, we can intercept them, and because we're capable of full RFID communications as both a tag and a reader, we can actually understand the reader queries, which means we can receive them, essentially extract the information about what is the RFID reader trying to do. You can then filter the information based upon whether or not that's interesting to you, and you can log it. So if, let's say, they pass some legislation, let's say in Europe, saying that, there's this, privacy directive thing, essentially saying if any personal information is being gathered on you, you have to be informed. So, what if, you purchased something from the Metro Future store in Germany, and what if they didn't post a sign saying that they were performing RFID queries, perhaps even on the items that you just purchased? They're breaking the law. The question is, how do consumers have any kind of legal recourse if the company is playing against the rules? Because right now, consumers just don't know, because they can't see the RFID activity. But with something like an RFID Guardian, granted not everybody's going to carry one of these things, but if you have a few gearheads that do, if enough of them notice that this particular store is misbehaving, then they can go ahead and perhaps go to the Chamber of Commerce and complain, and actually get the store in trouble for their misbehavior. So this really is about putting some power back in the hands of the people here. Also, you can audit RFID tags, by the way. So if, for example, somebody gives you an extra RFID tag, let's say you left your home first thing in the morning and you had one RFID tag. You return back at home at the end of the day, and now you have two. The question is, where did that second RFID tag come from? Did somebody slip it in your backpack when you weren't looking? So, when did you get it, for example? Could you get maybe a timestamp showing when you received the second RFID tag? Well, the point is, if the RFID tag is compatible with the RFID Guardian, yes, of course, this only works if it's at a compatible standard and a compatible frequency to the RFID Guardian. Once again, our system does have its limitations. But as long as they're using tags that the RFID Guardian knows how to deal with, you can actually log when that tag was received. And once again, it puts a little bit more transparency into RFID activity in the world. Key management. So some RFID tags do have security features. I was talking about a lot of the really good research that other people are doing in this field with on-tag crypto, things like sleep and wake modes for RFID tags, security protocols. But anytime you start getting into these on-tag security features, you start having data that's required, secret keys. I mean, how can you kill, an RFID tag without having its kill password? Because if you didn't have a kill password, then anybody could randomly go killing your tags. Same thing with sleep and wake. You're probably gonna have a sleep password, and you're also probably gonna have a wake key. Same thing with the tags that do crypto. RFID is a company, they got a little bit lambasted by Bruce Schneier for using proprietary crypto, but regardless, there's some crypto tags that are available. They also have secret keys that you use for the cryptography. So the question is, when you acquire these tags in the first place, how do you get the keys? How do you manage them? How do you use them? I mean, let's say I go shopping. Let's say I go to a supermarket and I buy an RFID tag, an RFID tagged item. I mean, maybe I would like to immediately put the tag to sleep, since maybe that tag actually has a sleep function built into it. Well, the fact of the matter is, I need to receive that tag from let's say the supermarket cash register, and then I need to, on top of that, actually perform the command that puts the tag to sleep. So with the RFID Guardian, you could actually perform this key transfer using RFID. Now, how do we do this? And this is also something we have actually already implemented. We do SSL over RFID. It is completely ugly and horrible, and the bandwidth sucks, really, but it works. So what we actually can do is, on the behalf of the RFID reader, let's say owned by the cash register, they don't actually need any extra hardware to be able to perform. So essentially, they just use, they could use either public or symmetric key crypto to set up an authenticated session between the cash register and the RFID Guardian. And it can basically, using SSL over RFID, transfer the keys. And then once the RFID Guardian has the keys, then it can use its built-in RFID reader then to put the tag immediately to sleep. So this is another part of what it can do. Access control, this was the whole firewall functionality I was telling you about, and authentication. Once again, not all RFID tags can authenticate themselves, so instead we have the RFID Guardian authenticating the RFID reader on the behalf of the RFID tag, and then it's also, because it's also controlling the access of the RFID tag, then it's almost as if, with the individual tags that they would be, controlling their own access and performing the authentication themselves, except for the fact that when you step out of radio range, then it doesn't work anymore. So here's an example access control list. What you're going to see is that it looks a heck of a lot like a standard access control list, except we put it in a kind of pretty BibTeX-like format, but ignore that. So here's what the rules look like. So rule protocol 15693, this is what we have for this particular one. So let's say you want to, by default, we want to leave all RFID traffic alone. That's the first rule, because of course we don't want to interfere with other RFID systems if it doesn't belong to us, because we're really good and benevolent people. But generally, we want to block all queries to our tags. So the second rule might be, I would like to deny any RFID queries that are targeting tags, let's say in a list that I've constructed of ones called TI white. So we have particular tags in our lab that are from Texas Instruments that are little white keychain thingies. So we said, let's just actually block all the queries that are going to these tags. So we made a list of them, and like a normal access control list, like you would define, for example, a list of IP addresses, we define a list of RFID tags. Third rule, but we would like to let an RFID reader, let's say that's in the trusted category, to be able to access the tags in the group TI white. And what is trusted? Trusted is simply nothing more than a role that is represented by a key. It's just role-based access control, most standard stuff in the world. You basically just give the RFID readers, let's say, you could have a key for readers at home, a single key for readers at the office. Who knows? Kmart or whatever, Walmart might have an entire PKI for these things, but essentially you can make it as simple or as complex as you want in deciding who you want to let access your tags and who can't. So, all right, I talked about privacy functionality. So our most recent work, and this is the stuff that is really like brand spanking new, is how do we actually also use the RFID Guardian for security instead of just for privacy. So right now, RFID deployers make a lot of stupid mistakes. You want to know, more information about stupid mistakes? You heard, Lucas's talk earlier today. The fact of the matter is, right now, I would posit to say there is no RFID security industry. But I think maybe there should be. Because right now, governments and companies are making egregious errors. And essentially, okay, part of the problem is you need to slap them upside the head before they do something about it. However, there really also are players out there that have good intentions and really want to fix these problems. I mean, for example, I was talking one time with NIST in Gaithersburg, Maryland, and they were busy working on a system for something called HSPD 12, which is Homeland Security Presidential Directive 12. So President Bush, after 9/11, decides, he wants to look like he's doing something. So what does he do? He basically mandates that they have to make a single system for authentication and access control for the entire federal government. Yeah, a little bit important. So I'm talking with NIST. They'd actually sent me a copy of their standard that they were working on, basically asking if I could evaluate it. Of course, I took a look at it and sent them back, a nice email saying, "My God, why are you using RFID in this in the first place?" But that aside, I was speaking with them after that, and they said, we really, really want help with designing this system. But we've gone to RSA Security and asked them if they could help us, and they said that they were too busy, which is logical because they're just a company of about 10 people. Plus they've got their hands full with Secure ID and with all the other wonderful things that RSA Security does. They've really only got one full-time person, more or less, on RFID security. I mean, and they went to us saying, please, can you help us? I was like, I'm a PhD student and I have a dissertation to write, so, I can't help you with this. I don't have time to help you with this either. So a lot of them really have good intentions and they want help, but right now there is no place for them to get it. The reason why, there's lots of security people. There's tons of computer security people. That's why we have conferences like this. However, how many security people now know how to properly audit and penetration test RFID? Raise your hand if you know how to do that. Lucas raises his hand. But the point is that right now the tools are really not out there. So we figured that we were going to work on building some tools so people can actually get a head start with learning to bring their computer security expertise into the domain of RFID, just so we can start getting these companies to stop making these damn stupid mistakes. So the first thing we took a look at is fuzzing. Of course, we've had lots of talks on fuzzing, today and yesterday. So we figured, how can we do this for RFID? So we figured we can actually do this on 3 layers. So at the bottom, you have the framing layer for RFID. At the second layer, you have the command layer. And at the top, you have the application layer. So with the framing layer, I was describing before, you have starts of frames, bits, CRCs, and ends of frame. Well, there's lots of ways that you can manipulate this. For example, bits for the ISO 15693 standard are constructed out of half bits. What you can do, for example, is give it invalid combinations of half bits. Other things that you can do, and actually how it constructs the half bits, is it uses something called Manchester encoding, which essentially what it is for the non-EEs amongst us, I'm going to describe this really gently. You essentially have 5 volts and 0 volts, and Manchester encoding essentially looks at the timing between the high and low transitions. So it's actually all about the timing. So what happens if you just give it complete, total, random crap timing? Well, the answer is, and we tried this on a Philips reader of ours, is that eventually the RFID reader starts flashing. It gets slower and slower and slower, and you look at the memory consumption and it's not very happy. And I do have to say that one time with the RFID Guardian version 2, actually back when the RFID Guardian was misbehaving, we actually did get this particular application to crash. Details about this will be in some later talk. But the point is that this stuff, we have seen this work. And it's just, it's fuzzing like for anything else. It's just like fuzzing with wireless Wi-Fi device drivers, but now it's just, the next generation. Now it's, the next horizon. Now it's for RFID. Nothing new, but just new domain. Command layer. So with the ISO standards, you have a lot of different commands. For example, you have, what you tend to have is, like you could have inventory commands, or you could have read or write block commands, or other commands that ask what kind of a tag are you. The point is, what you're going to have is commands, you're going to have flags, you're going to have parameters, oftentimes you're going to have data, and then you're going to have another checksum. So there's lots of things you can screw around with. What happens if you give it an inventory query without having the inventory flag set? Depends on how it's implemented. What happens if you tell it that the amount of data that you're giving it is only, so many bits, and you accidentally give it more? Implementation dependent. What happens if you give it a non-inventory query and you do have the inventory flag set? How does it handle all of these things? And basically we've been working on a script that goes through the random combinations of these things so we can actually test it out. And right now our poor little, Philips RFID reader is undergoing this kind of testing at the moment. So, application layer. So on top of RFID, you're probably going to have some kind of an application, whether it's a supply chain application or whether it's something you're using to purchase your gasoline. Well, the point is that oftentimes there's a database involved. I mean, I told you that, SAP and Oracle and IBM WebSphere and all of these, well, they're all coming up with RFID middleware. Well, I demonstrated, before in a little test environment that you could do SQL injection attacks via RFID. Well, how do you automate this? There are tons of tools out there for fuzzing the application layer of things like databases. Wouldn't it be cool if you could do it over the RFID interface? Well, we thought it would be really cool. So here's what we got set up, and here's a little sneak peek of what we've been doing with the app layer fuzzing. So we partnered with a company called Beyond Security. They're Israeli. Actually, the guy who got me hooked up with this in the first place is a guy named Gadi Evren, who also is a frequent speaker on these kinds of topics. And they have been so kind as to essentially lend us free usage of their generic fuzzing platform in exchange for us sacrificing a few grad students to actually do the real, elbow grease kind of work. So what we've got is, this is BStorm that you can see, which is their generic fuzzing platform. As to be expected, it generates random crap. I mean, that's what we expect it to do. And what we do is the RFID Guardian. So this is the input that you would give to BStorm. And essentially, we actually had to write sort of an XML kind of template to represent what the tag information would look like. And what you're going to see then is you're going to have some tag data that you're going to have here. You're going to have a tag ID. All of this stuff is sort of going to be represented with XML. And we have hooks then that we can use to essentially take the output of BStorm and to basically hook it into our tag spoofer. Because once again, we can emulate RFID tags. So we can give it any tag ID we like. We can give it any data that we like. We can give it anything. So what happens then? The data goes over, the RFID interface, over the, in through the RFID driver. And sure enough, if you take a look at the back-end database logs, you start seeing all kinds of really weird entries in the database logs. Where did this come from? It came via the RFID driver, which then, comes over the air interface from the RFID Guardian. So it's just one more way into the system. But for the rest, usual old tricks, absolutely nothing new. It's just a new way into the system. And of course, when something is found, then BStorm says, potential vulnerability detected, and then you can go pursue it a little bit further with a built-in kernel mode debugger that the thing has. Or you can use your own, or you could probably write, your own Perl or Python script or whatnot if you don't feel like using BStorm. We're basically just trying to do a proof of general concept on these things. But so this is what we're doing with fuzzing. Another thing that is a little bit less developed, but we're also working on, is differential power analysis for RFID. So I did mention that it's, the RFID Guardian is a software-defined radio. So, one of the things that it can do is receive RFID signals and then send it to a very powerful processor. What is that good for? It's also good for things like differential power analysis. So what we've actually done is we've built a new probe, specially tuned for 13.56 megahertz, and we're working together with a company called Riskier that's in Delft in the Netherlands. They actually built a DPA platform called Inspector that we're also using to essentially test out some things with DPA. This is all really preliminary stuff, and I'm also running out of time for this presentation, so I'm not going to talk about this stuff in length, but I just want to say it's something in the pipeline, so, and I'm expecting good things with it. We're actually busy attacking right now a dual interface card that uses S. And we know for a fact that it's a weak card because it's already been attacked via the contact-based interface. And part of the fundamental questions that we actually want to answer is how much more difficult is it to attack it via the wireless interface as opposed to attacking it via the contact-based interface. But once again, it's old tricks. It's just old tricks in a new domain. So our project is real. Our project has been implemented. Our project is still being implemented. And we want people to download and play with what we have created. Our project is open source. The software is all available via the GPL. The hardware is available via the MIT license for the schematics and Creative Commons for all of the board artwork. So if you know how to make your own hardware, everything you need for the Guardian. Also the Verilog is also online for the FPGA. If you know how to make your own hardware, everything is online already, so you can actually make this and play with it already. A lot of people have been asking us, yeah, but we don't know how to make our own hardware. You know, can't we just buy one? We're actually talking right now with a funding organization in the Netherlands who will remain nameless for the time being, but we are this close to getting seed funding for 3 years to actually start actually really producing these things. Also, a very prominent businessman in the Netherlands, maybe you guys have heard of him, his name is Rob Groengaep. he did something with voting machines. He actually also is going to be helping us out with the business side of things. So we have all of the ingredients there to make this real. Essentially, part of what we need is just coordinating it and getting it all together. We're working on this on my side. But another thing that we would also love is support from the community. So if you guys support this project, would like to support this project, there's a couple things you could do. One, you could go to our website and just send us an email. We're actually right now trying to estimate how many of them we want to make. So right now on the website it says, would you like an RFID Guardian? If so, please, send us your email address and your name and an approximate price you think is reasonable and or the reason why you want one. So if you guys think it would be fun to play with one of these, send me a mail and I'll put you on the list. But also, this is an open source project and I want to turn it into a living, breathing, contributing, kind of project. If any of you guys are software developers, even if you don't have the hardware, we have an emulator available for this. So you can actually still perform development with this platform without having the hardware. So if you want to download the software emulator and play with it and propagate any kinds of changes or improvements or new features, please feel free to do that. For the rest, if you have ideas for new features, complaints about things that we're doing wrong, just any kind of feedback at all, I really encourage you to send it to us because we really need all the help we can get, but we really think we're creating something that's useful for people. And we hope that you agree. So for the rest, that is it. Here's my contact information, so please feel free to contact me if you want any information about this, and I would be happy to take a few questions. So thank you. All right, yes?
Question about legality. When you start selling these things,
yes.
Don't you think that somebody will start detect your device and say, well, I see someone walk into a Walmart, turn on this thing and just take up 3 laptops and walk out, blocking all their RFID signals?
Yes, I anticipate this could be a problem, but you know what? What we are building is essentially a pen testing device. And it can be used for good things, and it can be used for bad things. So as a result, you're going to have the usual, full disclosure issues that you have with any other kind of pen testing software. So can people abuse this? Yes. But I still think that it's better that at least the good guys have these kinds of tools in their hands so they can test their own systems, they can pen test their own systems to try to make it resilient to these kinds of attacks, as opposed to only having, the bad guys having systems like this. Because let's be honest, this wasn't that hard to build. I mean, we had essentially a bachelor student doing most of our hardware design. So I mean, it really wasn't that hard to build. So I mean, yeah. So yes, it could have legal issues. We're also even looking for students, perhaps, part-time to do some, looking at these kinds of issues, so we can write another paper on it. But yeah, it's a good question. So, yes?
Is there a way to detect that the Guardian's there? So is there any way how it's different from the initial reader?
Well, I mean, if it's doing something like selective jamming, I mean, I suppose if you notice that a tag is always blocked, I mean, that could be a way of knowing that a Guardian is there. But, I mean, we're just sending out random noise, so, I mean, how do you know the difference between a Guardian and normal environmental radio noise? I mean, if you're not actually, really paying attention, I mean, it probably would be fairly...
Yeah, but I think as soon as this device will be out, they will make countermeasures.
Right, and I'm sure people will make countermeasures because, of course, yeah, look, this is a cat and mouse game. And I mean, as far as criticisms, we've gotten criticisms already for the Guardian. I mean, some guy put out a blog entry saying, why the RFID Guardian, like 7 reasons why the RFID Guardian is not enough. We're already starting to get this. And, part of what he was saying was, it's, you should have multi-layered defense instead. He's completely right. We just have one solution out of many. But, I mean, the point being, people are gonna start attacking the RFID Guardian as soon as it's available. Another thing is we need to use secure programming for the RFID Guardian because, of course, once it's out, people are gonna start attacking the RFID Guardian. I mean, heaven knows this has happened with other kinds of privacy-enhancing technologies like Tor, so it's not gonna be any different with our technology either. So I'm fully expecting this. Yes?
So I was wondering, I don't know that much about RFID, but if you use a directional antenna, would you be able to, because of course the Guardian can only pick up if you aim something exactly at it. I don't know, can you make a directional antenna to basically query one RFID bypassing the Guardian? Yes,
this is a completely valid way to bypass the RFID Guardian because the RFID Guardian cannot stop an RFID query that it can't hear. So if you build a Yagi antenna and you point it right at that RFID tag and the Guardian can't hear it, it can't do anything about it. But it does make life more difficult for the attacker because he needs to know exactly where that RFID tag is so he can point it. So, I mean, yes, this is a valid way to attack it, but the attacker really needs to know what they're trying to accomplish with this attack. So, any other questions? Yes?
I want to counter what was said first. There are a lot of threats. I've done some threat modeling for customers for RFID use, and there are a lot of really scary threats. And a tool like this is absolutely urgently needed. And abuse, for example, for stealing something of RFID is trivial. You just glue a little bit of aluminum tin foil on the RFID, and it's dead. So misuse of RFID tags is very easy for the criminal part, but analyzing the security is impossible without a tool like this, and for that reason, this tool is invaluable.
Yeah.
Don't get me wrong, I think it's perfect, I think it's a great idea, but if you don't think about stealing, if you think about someone walking through an airport and blocking someone else's passport, getting into trouble, things like that, I mean, there's tons of attack vectors.
Look, let's save this discussion for afterwards. But I have to say I agree with both of you. I mean, also another thing people ask all the time is, why do you need an RFID Guardian? Because you can just put your tag in the microwave and you can just put aluminum foil around your tag. I mean, they're right. You can, but it's much more coarse-grained access control than if you're doing it via radio. So. All right, are there any more questions before we wrap up? Yes?
Yeah, one more question. You were saying like how RFID chips were getting, there's more and more space available for storage and such. Probably going to get smarter as well, so why not actually put all these kind of tricks on the actual RFID chips?
Okay, there's a number of reasons. One, I think if you can put security on an RFID tag, you should. Because like other people have been saying, I think multi-layered defense is best. However, what are some advantages of doing off-tag protection as opposed to on-tag protection? Probably the most important one is key management. Because you could have an access control list on every single RFID tag, but what happens then when you want to update your policy? What happens if you want to update the key? Because occasionally it's kind of nice if you can refresh keys and things like this. I think in such a way it's much more easy to deal with if you have a centralized platform as opposed to just trying to manage all of this in a distributed fashion. So I think it's good to have the primitives there, it's good to have the tools there. And another thing also is that RFID tags in some scenarios are supposed to be cheap. And for the, I mean, you're right that tags are going to keep getting more powerful, but also there's going to be a demand for lower and lower end tags and cheaper tags. Once they have the 10-cent tags, they're going to want the 5-cent tags. Once they have the 5-cent tags, they're going to want the 1-cent tag. Once they have the 1-cent tag, etc. So the point being, there is always going to be a low end. And I mean, how much, what that low end is details, and that's going to evolve as time goes on. But there's always going to be, it's a fundamental problem that it's the low end of computing, and there's always going to be a low end of computing. So the fundamental question is, how do you protect the low end of computing when it can't protect itself? So I think these kinds of issues are relevant no matter what. So last question.
Yeah, if it's actually money issue, how much is this Guardian? I mean, to build this hardware?
Yeah, so right now we're trying to have a price point probably of around $200, $250. We're assuming that's going to be realistic for manufacturing it in reasonably small quantities. We want to make it cheap enough that people can purchase it still kind of as a toy. But right now the most expensive component is basically the PXA processor, the development board. We're actually going to be phasing that out probably in version 4 of our design, just simply due to the fact that these little Triton modules are too expensive. It's about 130 euros for one of these modules, and people, I mean, that's more than half of the cost of what we want this to be, so we're going to have to redesign that ourselves. But that being said, we want to make it cheaper, and it's all in how many quantities people want these things. But like I said, in the long run, if people really want Guardians, if somebody could make a one-chip version of these things, I have no doubt that it could become as cheap as any other radio I see. I mean, and that's really, the low end of it. Because if you then attach it to, perhaps the X-scale processor in your cell phone, all of a sudden you've got something on scale that you can really distribute. So right now we don't have ourselves the facilities to do this, but I mean, maybe someday it'll happen, maybe. So. But yeah, I mean, what we want though is, once again, if any of you guys either are hardware engineers or know hardware engineers that would like to help us with the engineering effort, I mean, one of the top things on our list right now is get rid of the Triton module. So if you know any people who have some chops in hardware design and want to help us with this, please, because I mean, the more people we can get helping with this, the quicker we can actually get it to you guys. Hopefully, also with a bit of the seed funding, we can also hire some professionals to be helping us with this, as opposed to just having wonderful bachelor students doing it. But yeah, we'll have to see. We're doing it as quickly as we can, but this kind of stuff does take time. So, okay, well, thank you for coming.